Hi there, it's Toby. So I am going to continue the series where I create a programming language from scratch on stream. Only this time, I'm not gonna do it live because I found some connectivity issues with the streams lately. It's the quality hasn't been very good, so I'm gonna just record this one and then upload it. One thing I wanna bring to your attention is I added an enhancement to my website recently, which is transcripts for videos. So if you're interested in this series, for example, you can click into the link for this video, and you can see a transcript for this video, and also this transcript is generated automatically by YouTube based on the audio, and it may not be 100% accurate. However, I thought that it might be helpful for some folks because some of the videos, some of the materials I make are quite long, and with the transcript here, you might be able to find just the bit you're interested in and skip to that part. For example, you can next to each line in the transcript, there's this time marker here, which you can click on, and then it'll jump the video there. So yeah, if that's interesting to you, if you think that is helpful to you, then it is there available for you. Okay, let's get back to this series. So in the last episode of the series, which is episode 5, we implemented this curious concept that I kind of invented on the fly, which I called it tags, which is kind of what they are. So this is an example of a tag. So this curly bracket syntax, I'm using it for various collection types that we have in this language. And I realized that sometimes I want that to be an array, and other times I wanted that to be a set. I felt it would have been cumbersome to have a entirely different syntax for a set versus an array, and I also kind of didn't want a function for some reason. I don't know why. I kind of didn't want to, like in Python, they would just say like, hey, just make a function that would initialize a set and then you're done. For some reason, I didn't feel like doing that. So I said, I'm gonna give it a tag whenever I write a collection literal like this, and then the language would know which type of object it is. So that's what I did, and I'm planning to use that for dictionaries as well. So a dictionary would look, well, although in the case of a dictionary, you don't strictly have to use a tag, because for dictionaries, you can actually use the key value pair syntax, which will differentiate it from arrays and sets. So you can say like, I don't know, 1 goes to 2, and then maybe 3 goes to 4, and so forth. So that's a dictionary, and because of the syntactic difference between this one versus this one, you don't necessarily have to have a tag, although if you use the tag, it would also work. So I think this time I'm going to implement dictionaries. That's the plan. So let me make a example of a dictionary. So I made a full example. Let's see. I made a full example here, which does have this dictionary syntax. So I'll use that. So I'll make a file called example dict.x. So you can make a dictionary with this tag. I'll just call this dict1, and then maybe another one that where you don't use the tag, so that we have both cases accounted for. One thing I do want to do with this dictionary implementation is that I want the keys to be able to have any type, unlike JavaScript, where the key can only be a string. I want this to be more like Python, where the key can be a number or a string or even an object, another dictionary or an array. All of those things are allowed. Let me get rid of this activity bar. Kind of is a little bit distracting, so I'm gonna get rid of that. And internally, I'm planning to use the ECMAScript map to implement it, which does allow for keys of various types. So if you search for mdn map, the way you make a map is with the new map constructor. You're not supposed to access it like this though. They're saying this still sort of works, but doesn't behave as expected. You're really not supposed to do this. I mean, we got these red lines next to these code examples. You're not supposed to do this. Don't do this. You're supposed to call map.set to update entries on the map, and map.get, I believe. Yeah, map.get to access entries within the map. And again, the key can be objects or other types of values, and that's fine. So that's what we're going to use internally for our dictionary implementation. I think it's going to be great. So first, we're going to need to implement the parser. So let's go into the grammar. This is some grammar. So we have statements, and a statement can be an assignment, a function call, a function definition. We have expressions. I think that's what we are looking for. Where's an expression? There's an expression. So what can an expression be? It can be an identifier, a literal, a function call, a code block. We want to go for a literal. We have a sequence literal, which used to be a string literal, but at this point, a sequence can either be a sequence is either an array or a set. Maybe in the future there can be other things too. Maybe like a linked list could be a sequence as well. But this time we're really concerned with dictionaries. So what I'm gonna do is add a dictionary literal to the mix and define the grammar for that. It will have an optional tag as well, I believe. So alright, so a dictionary literal. Okay. How do I write this? This series has been on hiatus, so I'm having to remember how I do things. So we're going to allow an optional tag. If they don't provide the tag, this will just be represented as a null value. So my AST sort of converter has to know that somehow. I think it defaults to some tag, maybe? I don't remember. Oh yeah, here. It defaults to array in the instance of the sequence, but for a dictionary, actually, I mean, for a dictionary, I don't even know if there can be different types of dictionary. So whatever. So dictionary is also going to be enclosed in curly brackets. And then we're going to have some optional white space, and then we'll have a collection of key value pairs. I'm going to call this key value pair list, perhaps. And then we're gonna write a converter for it, but I think I'll defer that. I'm also gonna write I'm gonna write this definition for key value pair list first, but before that, I'm going to write the syntax for an empty dictionary. So, for the empty dictionary is when you will actually need a tag. Yes. Actually, you know what? Maybe I should not. Let me think about this. Wait. Houston, we have a problem because let me think about this. So the parser will recognize this as a sequence literal, actually. And if it recognizes that, so there's an ambiguity in the language if I were to add this clause. So one way to think about it is well, this guy is not necessarily a sequence literal, is it? It's a collection, because a sequence is only a set. So like a sequence is either an array or a set, but let's say a collection is either a sequence or a dictionary. Let's say that. Is that fair? I mean, I'm making this up, so I can say. So I'm gonna actually redefine or rename this guy to something. I'm gonna call this the empty collection. Empty collection literal, actually. Whoopsies, I need a here. Yeah, empty collection literal. And I'm gonna say yes. This is what I do. Yes, this is good. I like this. So I'm gonna separate the empty collection literal from the sequence literal and the dictionary literal. So an empty collection literal is neither of those. Yeah, I think that's a good way to handle this. But if the tag name of an empty collection literal is a dict, then that should be allowed. And I'm gonna say, well, if tag name is dict, then it's a dict literal, and then its entries will be maybe this can even be value, although no. No. I think entries should also be an array, because we'll say it's a array of 2 element arrays. That's what this is meant to be. It's an array of 2-element arrays where for each containing 2-element array, the first entry is the key and the second entry is the value. So let's do it like that. So I'll call this entries. It's a dictionary literal. Else, it's either a set literal or an array literal, and it's got items instead of entries. Okay, let's go with that. I think that's okay. And then now for the dictionary literal. So let's define the key value pair list. I think that would be, it's either a key value pair or, or it's a key value pair and then some mandatory white space and then another key value pair list that comes after it. But what is a key value pair? Well, a key value pair is an expression, I think, and then some optional white space, a colon, some optional white space, and then another expression. I think that's what a key value pair is. So yeah, I think that probably is right. So, and there are no commas, by the way. So yeah, this is what I envision as a dictionary. Oh shoot. In order to allow a new line character here inside the white space, I think I actually need to do some extra thing in order to handle that. I'm gonna defer that. So for now, I'm just gonna do this. Something like this. One tip for programmers out there is try to do one thing at a time. Don't overwhelm yourself by doing multiple things at once. So this is what I'm doing. Instead of trying to handle that extra case that I just realized I needed to handle, I'm gonna defer that and just handle this syntax without the new line, without the possibility of new lines in there, because that's another piece of complexity that I would have to deal with, and it would be easier to deal with it separately on its own once I'm done with this particular task that I'm on. So let's try this. I'm gonna write the converters for each of these grammar rules to convert the bits to a JavaScript object, an AST representation. So I think I'm gonna, for a key value pair, I think I'm just gonna represent it as like a 2-element array like that. So yeah, so I think that's just going to be, I'm gonna have a function get data that gets me the data, and then I'm gonna return a array, as I said, and then the key is gonna be the 0th element of data, and then the value is gonna be 0, 1, 2, 3, 4, the 4th element of data. Okay. So that's the key value pair. And then here I'm going to represent a key value pair list as an array of these arrays, an array of 2-element arrays. So it would look like key 1 value 1, key 2 value 2, etc. Okay, so in the case of the singular case where we have one single key value pair, I'm gonna do return an array that wraps around whatever that guy returns, which would look like that. So, but I do have to unbox it because this guy would come in an array with just that one element in it. So I'm gonna unbox that. I guess I could have just returned data and it would have done the same thing, but I think this is more explicit and that's fine. Okay, now for this case, I'm gonna return, I still have to return an array. I think I'm gonna use the fancy array spread operation, but the first entry is gonna be the 0th element of data. That's an array that I do not want to spread, but the result of that is the one I do want to spread. So that would be in index 0, 1, 2. Okay, so I know that this guy is going to return an array. As long as I make both of these cases of the rule return an array, which I have done. So that returns an array and that returns an array. So this guy's going to return an array. I get the array, spread it into this new array, which has this thing in the beginning. And that should get us another array. That has the what we want. Finally, we have this dictionary literal. For dictionary literal, I want to return something like this, except the entries should be what came back from here. So I do want to verify that the tag that we got, the tag name that we got, I want to verify that is a dictionary. So if it's not, then Hilson, we have a problem. And we're just gonna throw an error. So I'm gonna say, what did I say last time? Tag a sequence as a dict. I'm gonna say tagged a dict as a whatever you named it. Okay, so it has to be dict if we have a dictionary literal. But if you have an empty one, then you kind of don't know whether it's a dict or an array or a set. So we're gonna default that to array if you don't tell us. But if you want an empty dict, you have to tag it. Right, I would say dict3 is an empty dict. So that's not gonna be a dict. That's gonna default to be an array. So you have to tag that as a dict. That's how it works. Okay. So I really like the aspect of this project that I'm just making stuff up on the fly without being concerned about whether it's a good idea or not in the long run, because this project is meant to be a toy project, so you can kind of improvise without much bad consequence, or I should say mistakes will have little consequence. So here I want to return a, wait a minute, this code needs to go inside the arrow function. I realized I don't have the nearly.js syntax highlighter, but that's okay. I don't really need it. So now I'm gonna return a object whose type is dict literal, and its entries are gonna be whatever that guy returns, which will be on index 0, 1, 2, 3. So data index 3. Okay, so that's my dict literal. I'm gonna test the parser by itself, see if that worked before adding the feature in the code generator. So let's do that. So I have this directory is getting too messy, so I may clean it up soon. But for the moment, the example I want is dict example. So I'm gonna do node parse.js dict example. It doesn't like it. Oh, I need to generate the parser. npm run gen parser, which runs the nearly compiler. Now I'm gonna parse it again. Still doesn't like it. Why is that? Did I put the dictionary literal in the list of literals? I did. Oh, it's the lexer. This is a lexer error. So I need to teach the lexer to parse the colon. So that's easily fixed. Okay, because we're using Moo.js as the lexer that pre-process the string input before it gets into the grammar. The lexer needs to understand every type of character that goes into the source file. So hopefully this fixes it. Tagged dict as a dict. Okay, I tagged a dict as a dict. I mean, that seems good, right? If the tag name is not dict, then throw the error. But you told me it's dict. So I don't get it. Which line? 134. It could be coming from... Okay, I could look at grammar JS, line 134, even though I didn't write this code. So this is for the... we usually don't look at this grammar.js file. Usually we only look at this grammar.ne file, but we're gonna look at it now because this grammar file, when nearly compiles the grammar file, it translates it into this JavaScript file, which is where the line number of the error is. So we might as well make use of that line number and try to get a clue to what's going on. I believe this is curious. I believe this is coming from this line of code. It just looks just like that code, but it says tagged dict as a dict. I'm only going to throw it if it's not a dict, but if it is a dict, why would you enter this? So what I'm gonna do is console.log the JSON stringify tag name. That way it'll put quotes around it, so in case oh, I see. Because it's a token object, not a string literal. I think I get it. Maybe. it is a token object that says dict in it. In the lecture, I had the less than sign and greater than sign defined. So I guess it's saying this guy is actually a token literal. I imagine if that's the case, then that it's wrong here as well. So we may need to fix that in both scenarios. Another way I could fix it is just fix it in this optional tag, the definition of the optional tag, because I imagine when I get this tag, well, actually here, I could fix it here. So this guy, I imagine, is going to be an object. I'm gonna print it out and see. I'm gonna return it, but I'm also gonna print out that the fact that I have a tag and it is a whatever that is. I think it's an object. And then I'm gonna remove. I think I already removed that printout. I'm gonna, because I edited the grammar file and not the JS file, I'm gonna close the JS file so I don't get confused. I'm just gonna work on the grammar file now. After I edit and save the grammar file, I have to remember to run the gen parser command. And then now I'm gonna try to parse it again, and yeah, it does say when it encounters a tag, it's a token object. So I'm just gonna pick either the value property or the text property out of it. It doesn't matter which one. I'm gonna pick the value property out of it, so the rest of my code can sort of happily be ignorant about that and treat that as a string. That is the tag name. And I think that should work now. Although I would say previously I did test the set. Wait a minute. Does the set actually work or no? Oh, I know why it worked. Okay. Okay. Because the token object has a toString method. Yeah, so that even if this guy was a token, it would successfully concatenate with this because the token object has a toString method that will, when you concatenate the token object with another string, it'll use the toString method to convert token into a string first. Okay, in any case, I think what I've done is kosher, so I'm gonna go with that. And now it was able to create an AST. Let me examine that AST file and see if it's good. Where is it? Oh, there it is. Excuse me. Okay, so we have, so this is the program. I'll do it side by side. Alright, so this is the program. We have a variable assignment. Variable name is dict1. And then the value we're assigning to it is a dict literal, which is correct. And within it, we got entries. The first entry has two things within the entry. The first one is a token. It's a number, and it has the value of 1. That looks right. And then the second one is a number. It has a value of 2. So that also looks right. So 3 and 4, that looks right. The second assignment, assigning to dict2, is also a dict literal. We have a string literal as the key and a number as the value, and then also second entry string literal as a key, number as a value. Third one, dict3. Also a dict literal, this time with no entries. Great, that worked. Gonna retest the array example, I think. Make sure that stuff still works. I don't imagine that I would have broken it, but you never know. So reparse the array example, and let's do the same exercise. So the example array, look at its AST. Okay, look at them side by side. So the first one is an assignment to a variable called R, and the value is an array literal with a bunch of number tokens in it. That looks right to me. Yeah, okay. I think the tag example is probably what I want to. So yeah, a dict equals, so this should be a dict. So like something like name equals Maria. Maybe age, oh, no comma, age is 10 maybe. But if you have an empty dict, empty arrays look like that, but empty set looks like this. You have to tag the empty set, and then empty dict looks like that. If it's empty, you have to tag it, otherwise it'll default it to an array. Okay, so that's how it works, and we'll tag the empty array too, just to be explicit. So let's parse this one. Okay, so we have a tag. All right, let's do the same exercise. We're gonna look at them side by side. Okay, so we're assigning to a variable called array. The value is an array literal with numbers, 3 numbers. Looks good. We're assigning to a set, and the value of that is a set literal with 3 numbers. Okay, so that's that one. And then we have array2. That's an array literal again. Good. And then we have a dict. This time it's a dict literal. Dict literal with these entries: a string name and a string Maria and a string age and a number 10. Perfect. And then next with empty array is an array literal with 0 items in it. That looks good. Empty array tagged, same thing. And then empty set is a set literal with no items in it. And then an empty dict is a dict literal with no entries in it. So all of that looks great. So now I'm gonna go ahead and work on the code generator. Which is in the generate.js file. So this code at the moment is actually very, very minimal, which is great. So for those of you who are following along, this is a great state of things because you can read through this code and without too much difficulty understand what's going on. So there's a top level generate function which takes a top level AST and generates a JavaScript program out of it, basically. And so what we need to do is basically add another condition that knows how to handle dict literals. What I'm gonna do is just, instead of adding that code, I'm actually gonna just try running the generator. and see it hit the error first. And there it is, unknown node type dict literal. It hit this error here. So that is supposed to prompt me to, hey, you need to handle that node type. So I'm gonna add a clause here. And I'm gonna generate a new map expression, basically, is the plan. So let me think. I think I'm gonna do a map over the entries. So say node.entries. So we can look at the AST while we write this code. I'll shrink this code a little bit. So let me look for a dict literal. So a dict literal is gonna have this entries property in it, and that's the one I'm going into. And because the entries, the value inside that property is an array, I'm gonna map over it. And then each entry is going to be an array of length 2. Each entry is gonna look like that. So the key is gonna, I can actually use this array destructuring assignment like this. I could even do that in the parameter list, but I don't feel like doing it here because the line is already kind of long. Or well, in this split screen scenario, we don't have that much more room. Anyway, so we have key and value destructured now. Key is gonna be an object, like an expression. In this case, it's a string literal, but it doesn't have to be. And also in this case, it's also a string, but again, it doesn't have to be. So we're just gonna ask our generate function to generate the JavaScript version for us. So I'll say JS key. I'll say key expression, key exper for short, is the result of generating the JavaScript code for the key, and the value exper is gotten by calling generate on value. Okay, so it will convert this token object or AST, or this could be actually a more complex expression like a 1 + 1 or something. Uses the generate function to convert that into a expression which is in JavaScript, and then given that, we're gonna actually format that into this JavaScript array that has a length of 2. So we're gonna format it into, basically, in this scenario, it would look like so we want to format it like this, and then so for each entry in the map we format it like this, and then finally for multiple entries it would look like an array of multiple arrays like that. So the way I'll do that is using this template string syntax. And then finally, when we receive all of the entries in an array, we'd use a join to put a comma in between them, and then after that, we're gonna make a statement that creates a new map and then puts those entries within it. So let me try generating the code now. Ooh, that's looking good to me. It wrote example tag, so let me look at example tag JS. that looks great to me. That's how you're supposed to instantiate a map. So yeah, so that looks like it worked. I mean, I will execute the program. Run.js example tag.x. Maybe I will even print out the map. Dict. I mean, yeah, the dict. In my language, I'm calling them dictionaries, but in JavaScript, ECMAScript, it's called a map. I'll print out a dict and as well as empty dict and run it. And yeah, we got these maps. Great. That's exactly what I wanted. Okay, so now in order to make the dictionaries actually operational, we want to be able to loop through them, access, set values in them, get values from them. I think at the moment our paradigm has been just provide runtime functions to do that, and I think our runtime functions are embedded in this generate.js file. So let's just add a runtime function here. We might extract this big string literal maybe into a separate file. Let's go ahead and do that. I'm gonna make a runtime.js, extract this big string literal into it. Possibly I might just let me think about this. I actually think I should just yeah, make this file a literal JavaScript file like this, and then when generate needs to use it, I'm just gonna use the file system to read in this runtime.js. So let me see. So runtime is going to be the result of await fs.read file. To make sure I read the file that's right in the same directory as this is the script itself, which in this case is the generate.js. I'm going to use the dir name. I'm going to use path.join the dir name to runtime.js. So this reads the file for me, and then I'm gonna do toString. Why did it plop another wait in here for me? I didn't want that. Oh, I did need a third parenthesis. Okay, because of this call to path.join. Okay, so now I think this runtime, this runtime is needed by this generate function here. And I either pass them in, but I don't feel like it right now. So I'm just gonna make a global variable. I'm gonna make runtime this global variable, which I will set up here. It's only referenced one time, so I kind of feel okay, not too bad about doing it. Although in general, it's not really a good idea. Okay, so let me try this. Run it, and okay, we still get what we have. So now, yeah, not feeling great about having this global variable, honestly. I could do read file sync instead though. I feel like that's actually slightly better, so I'm going to do that. So I'm gonna do it like this: read file sync. I'm gonna use the read file sync function, and read in the file outside of this main function, which is also not great, but I feel like slightly better. Okay, so I feel like this is slightly better because it's a const. Okay, and I think the use of read files, the synchronous reading of file is kind of okay in this scenario, where we sort of do need to stop the world and read in that file. Okay, so now we have a runtime.js which contains all of the JavaScript functions that will be available to the runtime when the transpiled JavaScript is running. We're going to add some functions to work with dictionaries. Probably, let me think. The way you iterate dictionaries, I believe, is you can call its entries method. I'm talking about map, actually. I think you can call map.entries. So I think I'm gonna allow it the iteration of a dictionary, aka map, just so that it I want to reiterate what I call in dict. That's the same as a map. Map is ES ECMAScript term, and in my programming language called X, I'm gonna call it dict. But I guess in in the context of what we're doing here, these two guys are interchangeable. Dict means a map, and vice versa. Okay, so I'm gonna make a function called entries given a dict. Should I call it map or dict in this runtime? I'm gonna call it map. It's gonna return map.entries, which I believe it's an iterator, which is not necessarily what I want. So I think I want actually array.from. We don't have the concept of iterators in this language yet. But if I do add it, then not now. I gotta do one thing at a time. Okay. And then now you can just call entries on the dict, and then after that you can do all of these other things to it that you can normally do with an array. We might need something for iterating over a set as well, but I'm gonna defer that. But with a dictionary, what you really want to use is get and set. So I'm gonna get a key, get by a key, and then in ECMAScript you do it like this. And then when you set, you put a key, provide a key and a value that you wanna put into that key. And you call map.set like that. Yeah, so that's how to work with the dictionaries. So I think we're ready to write a simple example of using a dictionary. So let me think. Do we have a split function for strings? Let's add one. Okay. let's add a split function given a string and a separator. We're gonna return string that split the separator. We have to wrap all of these native methods with functions because the programming language only has functions at the moment. It does not have methods. So if we have split, I'm thinking maybe we can. I'm jumping ahead actually. So let me do something like this. I can set the entry, set within dict3 foo, and I want to put bar in there, and then I want to print the result of getting it back out from dict3. And while we're at it, let's also print dict3 itself. So let's run that program. Example dict. Oh, the language does not have commas. I forgot about that. That's a design decision that I made early on. So that works, yeah. We're able to set a dictionary and get a dictionary. Are we able to get the size of a dictionary? What about the size of an array? Let's add that. How do you get the size of an array? Is it that size? Dot size? Yes, there's a dot size. For array, it would be dot length. What about set? I just had an idea, which is kind of exciting, I think. Set also has a size. Okay. So for all of the collection types that for which we can get a size or a length, whatever, it's kind of weird that for map and set it's size, but for arrays it's called length, right? So if we can somehow unify it so that there's a same function you call to get the size of any collection type, that would be pretty cool. And in Clojure they have a concept called protocols, which is a feature that we can implement in this language, and I think that would be a lot of fun to try to implement that, because I wrote a blog post a while back that talked about this idea. Polymorphism that just works. This is an article I wrote in 2015 that talked about this idea, and within it I even sort of imagined a language feature. If we were to extend JavaScript to have this protocol feature, I sort of imagined what it would look like. And now that we're actually able to build a programming language from scratch, we actually have the ability to do this. So I think this is very exciting. But again, one thing at a time. So I'm going to make a size function which takes either a set or a map. A set or a map, and it's just going to return that set or map dot size. But for arrays, there's a separate one called length, and that's going to return array.length. And for the moment, it kind of and yeah, I could make the same function handle both of them, but for now I'm not gonna do. I could have written an if statement here and have one of the functions handle both of them. For now, I'm gonna differentiate it, I think. So now I'm able to print the dict has size of dict 3 entries in it. Size is not a function. I thought size was a function. I looked up the docs, man. I totally looked it up. Like, there's a map.prototype.size, man. Oh, it is not a function. It's a property. It's a magical property. Ah. Okay. Did not know that. Okay, so the dict has 1 entries in it, and if we set another one on it, like set dict 3 garbage out, then it should have 2 entries in it. Okay, great. And we can also we can iterate through the entries, because we can do entries of dict 3, and that would give us an array, and an array of arrays, I believe. And then we can do a map, I think. So the key, maybe also add a keys function, but for now I'll say each takes a block, I think, and then it can have argument, I think, like this. So and I'll say entry, and then key is actually entry 0, and value is entry 1, I believe. And then I'm gonna like this. So for each entry in dict 3, let's just print out the key, and then we'll do an equal sign like that and the value. Let's see if that works. No, it does not. What? It's a parse error. It doesn't like this key. Oh, we don't have this index. Okay. We don't have a way to access an index yet. Oh, that is freaking hilarious. No, we do actually. Not an array index. We need the index notation, but that's not been implemented. So maybe I make a function called at 0 and at 1. So let's go make that function. You have to make things as you need them. So like you have an array, this is how you do it. Okay, let's see if that works. Oh, that works. Great. Beautiful. I don't need this extra space because the console.log will automatically put in spaces. So yeah, this iterates through all of the key value pairs within the dictionary. And we have a way of iterating through dictionaries now. This is great. So, okay. So we've accomplished what we wanted, which was to implement dictionaries in this language. Yeah, I'm pretty satisfied with this. So I'm gonna stop the stream here, and I hope to see you next time.